Hello friends, my name is Ram Nivas Sangwan. This session is about Btrfs, Btrfs or Btrfs or Btrfs, whatever way you want to pronounce it. I am going to introduce you the architecture, the commands, subvolumes and the snapshots about the Btrfs, the new file system for Linux. So the agenda of the session is introduction to Btrfs. What is Btrfs? History of B-tree file system or Btrfs, whatever the way you want to pronounce it. Architecture, which includes collection of tree roots, the diagram, Btrfs commands, copy on write concept, the subvolumes, managing subvolumes using command line, snapshots, SUSE Btrfs snapshot features, rollback, the snapper command, the snapshot directory layout. This is what all I'm going to demonstrate and discuss. So here we go. What is Btrfs? Btrfs is a file system based on the copy on write principle. It's a unique concept. Basically the idea was taken from Oracle, where Oracle has a concept of a file system with the name ZFS, which has a B-tree implementation. But Btrfs offers many more features, additional features, but yes, the foundation was Oracle ZFS. So initially designed at Oracle Corporation for use in Linux. It is open source. So that means you can get the source code, you can modify it, and you can create your own file system. The development of Btrfs began in 2007, and since August 2014, the file system's on-disk format has been marked as stable. The support for offline in-place migration for ext3, ext4, ext2 to Btrfs is available. Means you have the command, you can directly migrate your existing file system to this. History of B-tree file system, or the better file system. As I said, we have Oracle has its own file system with the name ZFS. So it's a Linux correspondent for Oracle file system ZFS, and based on B-tree structure of XFS. So it's a combination of two, B-tree taken from XFS and ZFS concept also taken. Developed by Chris Mason from Oracle in 2007. It was included in Linux kernel since version 2.6.29 RC1 January 2009, and version 3 available since July 2011. And it's default in SLES 12, SUSE Linux Enterprise Servers 12. Right now I've been using SUSE Linux Enterprise Server 12 Service Pack 3. This is the latest one. For those who don't know what is the B-tree concept, this diagram explains you the concept of B-tree, where we have a tree format, inverted tree format. The starting point is the root node. So if you look at in the figure, we have root node 30, 70, and these are the two data. Now 30 is pointing to another node, we call it as another node simply, which has the value 8, 25. 8 is further pointing to another node which has the value 1, 3, 5, 6, 7, all. Same way 25 is pointing to the another node which has 15, 23, 15, 21, 22, 23 and so on, and after that we have 26, 28. So concept is pointers from root to the less value on the left hand side and the more value, the higher value on the right hand side. And this concept continues for not only the root node but also other nodes. If you look at any node has the concept on the left hand side, you'll get the value lesser than that, and lower values on the right hand side you will get the higher values. and the order is ascending order. If you look at the leaf nodes, they are already in ascending order. The addresses are taken, so basically there are two parts in any node. One is the data and another is the pointer. The pointer points to the memory block and the data part has the actual data of the node. So we already essentially have two components always in any tree, the data part and the pointer part. The pointer, basically the two pointers, one is left side pointer, one is right side pointer. Left pointer points to the right left subtree, right pointer points to the right subtree. So we have concept of tree, subtree and sub-subtree, and finally we have the leaf nodes or the data blocks. That's how it works. The B tree concept works. It solves many storage challenges. Example, massive scalability goes up to 18.4 exabyte. Data integrity is enabled using built-in checksum. You can actually verify. There's a command for that, scrum, and you can verify that with using that. Dynamic expand and shrink. Yes, this is I think XFS does not allow you to shrink the file system, but yes, with this Btrfs, that's why we calling it as Btrfs, not Btrfs now. I'll tell you when to call it as butter and why to butter. Okay, so right now I'm treating it as Btrfs because it's better than others. So XFS does not offer shrink, but Better or Btrfs offers you to shrink or reduce the file system size, also to expand the file system size dynamically. You'll see how easy it is to expand and shrink, grow or shrink, or grow and reduce the file system size. Compression features, built-in volume management, so no need to have logical volume manager LVMs, that feature is already enabled inbuilt. Not only that, we have seen that a RAID is also implemented, so you can create the file system with inbuilt RAID or LVM. You don't require additional software, additional commands for that purpose. So Btrfs offers you all these features right out of the box. Ubiquitous use, so you can use it for server, cloud through desktops, even mobiles. Cloud ready, powerful snapshot capabilities, and the most important is copy on write. This feature makes it unique. No file system has a concept of minded file system has the concept of copy on write. You'll understand the difference, and I'll explain that very well, how copy on write concept works here in better file system. Btrfs max file size, just for your understanding, in contextual concept, just to make you understand how big the size is. Look at 1 byte, 1000 kilobytes, million bytes, billion byte, trillion, quadrillion, and quintillion exabyte, which is 18.4 exabytes. That's the size, the massive size of 18 exabyte is allowed in Btrfs. That's the power. So I was talking about the root file system. That was the concept of binary tree. Here we talk about the concept of Btrfs in terms of the root. Now you'll understand with respect to the Btrfs, we have a super block which is the root block or root tree, right? So on the root tree, what you have is extent root pointers, which is pointing to the extent tree. We have subvolume default pointer, we have snapshot snap pointer, we have directory items which consist of defaults and snapshot and all, and each of the subtree itself is again a tree. And the most important, if you look at carefully, is subvolume default pointer and snapshot snap pointer. Initially they are pointing to the same data block or the same tree. That's how the concept of copy on write will be clear to you. Why? Because when you create the snapshot, essentially only the metadata is copied, only the metadata is available, and there is no data block copied. In fact, there is no copy as such. So when the copy will be created, when the actually memory space utilization will happen, the moment you start writing something, the moment you change anything. It's just like a concept of processes in Linux. When we create, there are two ways to create processes. One is fork way. When we say fork way, essentially another process ID is created and the same memory area is utilized or used by that another new process, the new process, newly created process. The moment that process try to write, try to change the memory area, they take different ways and they part ways. By why? Because then the copy of that memory area is created, and when the process tries to write to that, it will write to its own memory area. That's how the two independent processes are created. Initially only process IDs are created, the memory area remains the same. Same thing goes here. The data block, data, everything remains the same, only the metadata is copied. The moment you try to write something, a new copy is created. And not only that, that's another important aspect, is only that block of data which is changed will be copied, or the new copy will be created. It has another advantage which I'll talk about later on. Yes friends, in this session itself, please remember the skillpedia.com is my own portal where you can learn and teach anything online. I have more than 15-16 technologies already uploaded and offered at a great discount. So join the skillpedia.com to learn online. Btrfs commands. Btrfs is the main command, main Btrfs administration command. It comprises of several sub commands like Btrfs file system, Btrfs subvolume, Btrfs device, Btrfs scrub. Now this Btrfs file system perform file system related task. Btrfs subvolume perform subvolume related task. Btrfs device perform device related task. Btrfs scrub perform scrub tasks, which basically consist of verification of the data blocks, verification of metadata and all. mkfs.btrfs create a Btrf file system. And Btrfs convert an existing ext2 or ext3 or ext4 file system to Btrfs. Let's take a look at the commands, as I think this is the right time to discuss some of the commands. Let's take a look at that. So here we are. What we have, my friends, is right now I have some 2 additional disks created on my system, and let's take a look at that. ls/dev/sd star. So if you look at, I have disk sdb and disk sdc. In fact, I have a disk sdd also. Sdd I will use to expand or grow the file system, to add later on, but SDB and SDC I'm going to use right now. So let's create a file system using the disk dev SDB and SDC. Okay, what you need to do is, first is you need to create the partition on this to be of type Linux. In fact, you don't require it if you are creating Btrfs. You can straight away create Btrfs directly from the raw devices. And right now these are nothing but 2 disks, SDB and SDC. Let's create a Btrfs file system directly from the raw devices. So the command is mkfs.btrfs/dev/sdb and /dev/sdc. It's that easy. mkfs.btrfs, dev sdb, dev sdc, these are the 2 disks, and here we go, created. So we have created 2 Btrfs file system based on this. So we have the UUID. Remember, even though we have used 2 disks, the unique ID will remain the same, UUID. So both the disks will have the together we have the space available is 4 GB. Sector size is 4096, and by default what has been implemented here is RAID 0 of 1 GB, RAID 1 is 1 GB, and system for data is 1 GB, and for system it is 12 MB. And these are the 2 disks. One is 2 GB, second is 8 GB, total 10 GB space available. But right now the RAID is created, so we'll go into the detail of how to check RAID, how to create RAID, and how to change the RAID levels also. With the way we want to treat it, we can actually use that. So that's absolutely very easy in order to work with the RAID directly using Btrfs. You can create RAID devices also. You change the file system from here. Right, let's take a look at that. Btrfs and file system, or you can simply type fi is work, or file system. You can type file system show /dev/sdb. So it will show you both the devices. Whether you select this or you select SDC, the result will remain the same, because essentially it has treated both these disks as one file system. So the file system has been created on both the devices or both of the disk, right? So in fact, the good thing here right now is, if we take a look at the ID or UUID of these, we can fetch that UID using the command blkid. So we can take a look at that also. Let's take a look at that. blkid /dev/sdb. Right, that will give the UUID of this. So this is the UUID of this device. Please remember, this UUID will remain common whether you use SDB or SDC. That is interesting part. Take a look at that. So whether you use SDB or SDC, UUID will, for both the devices, will remain the same. However, to identify individual disk, you have additional UUID sub. So this is for device B. Okay, this is for device B and this is for device C. So they are identified by UUID sub. So for us, for mounting purpose, we are not going to use the UUID sub. We are going to use UUID for mounting purpose. If you want to mount these devices or this file system using the UUID. However, we can mount it using label also. But to mount it using UUID, we can use this UUID to mount the file system. Alright, let's make a let's mount it. So for that, let's create a directory mkdir /btrfs. We already have it, so let me remove it first. rm-rf/btrfs. And now let's create it, because I'm going to mount it. I don't want anything to be available. I just want to clean I want a clean system. mkdir /btrfs. So the directory is created. Now I'm going to mount it. So I can mount using Btrfs. Okay, SDB or SDC, choice is mine. So or the UUID, I can use either way to mount it. So for that, let's mount the device. Mount /dev/sdb and /btrfs. So the file system is mounted. Okay, so what we have is the mounted file system on /btrfs. Let's take a look at the disk space. df -h /dev /btrfs. So this will give the space. Look at it, we have enough space, 10 GB space, 2 plus 8. As I said, we will divide it, we will decide later on, but right now the entire space is available. 8 plus 2 GB space is available, right? So SDB, it does not matter whether you use this or you use, but this is not the right way to look at the space utilized by the Btrfs, because the difference you will find here, the difference is you should use the Btrfs file system command for that purpose. So Btrfs file system df /btrfs. This is the right way to check the file system used by the Btrfs. This is a better way actually. So this will give the data, the RAID implementation, metadata, space, everything. You'll get all the details, complete details about the. So this is actual utilization, actual space details when used by the Btrfs file system. So this is how you can mount it. You can check the space, and this is how you can get the UUID also. Let's go and let's create a subvolume also. cd Btrfs, here we are. Let's create a subvolume. Okay, so to create a subvolume, Btrfs subvolume. Alright, create, and here we can create any subvolume. Let's create a space subvolume with the name rec space. Okay, subvolume is created. Now we have created a subvolume, right? We can now we can mount also, we can create files also. We can take a look at this file. The rec space is created and it is a subvolume, right? And we can create the files also here. Let's create some files. Touch rec 0, rec 1, rec 2, rec 3. Let's create 3 files here, and let's create a snapshot of this rec space also. How to create the snapshot? The command is simple: Btrfs subvolume snapshot rec space. Alright, and this rec space snapshot name, rec space hyphen, let's say 2018, and we are sitting on month 8th, right? So this is the name which I want to give. So the snapshot is created. ls-r will give you the details of the snapshot. Look at here, we are. So this is our subvolume which we created, and this is a snapshot which we created. So we have subvolume as well as the snapshot. Essentially, when you create a snapshot, point is that they are identical in terms of memory also, in terms of metadata also, but they will separate, they'll part their ways the moment you start writing. The moment you start writing the data, they are nothing but two different Btrfs subvolumes, and you can use any of them, right? They are independent, because ultimately the concept is copy on write. The moment you start writing copy, you're writing something, it will create a copy. Till now it is only the metadata has been copied, not the data, and there is no space utilization as of now. That's the important point. You need to take a look at that. Okay, let's continue the session. So I just demonstrated some of the commands: Btrf file system, Btrf subvolume, okay, mkfs also. You can try the same way, you can try the other commands as well. Let's continue. So is it actually cow? Does Btrfs comes from cow or from a cow? According to Chris Mason, it does, because he is the main author of Btrfs and says it should be called Btrfs as it comes from the cow. And the matter of fact is, cow here stands for copy on write, not the cow which you are seeing in the figure. Okay, enjoy. Copy on write. When we talk about copy on write, let's take a look at the little deeper inside the copy on write. Normal write: existing block of a file are overwritten when the content changes. That's normal write. But when we say copy on write, if the content of block changes, the changed block is put beside the non-changed block, which means we have both the copies: the existing data, old data, and the changed data or the new data. Instead, what we have is the metadata. So the metadata or the block list changes. So only the metadata is copied. The benefit is, which you, if you have if you are coming from a database background, this is concept of transactions. Because in transaction, if you remember, in database what we have is the old data and the new data for the audit purpose, and that's the best part of the this Btrfs, and that's the best feature. So implementation of transactions in the file system is easy, as old content is still available. That's the advantage. To get into the more detail of this, to understand it, take a look at this figure. A normal write, we have, let's say we have the sentences, like we have 3 data blocks, which is one data block is sun, second is, and third is shining. Now normal write will happen if I want to change this is to was. What we'll have is sun, and the old block will be overwritten, and the was will be written in that place, in that block, and the content will be sun was shining. That was the normal write. But when we use copy on write, the sun is shining, so the was will be written somewhere else, and is will still remain there. So only the metadata will change, which will point to the new data sun was shining. Does not mean that is will be overwritten. No, is will be still there, and it will only and the was will be written into a new data block which is free, and old data is still there. That's the advantage of copy on write. I hope it is clear now. Subvolume, as I demonstrated, I created a complete file system tree in itself. Why do we need subvolumes? What are the advantages of using subvolumes? I would say it is better organization, better management. Why? Because each subvolume in itself is an independent tree. So therefore the traversal or the speed definitely will drastically increase, or you'll get the faster access, because if you create 5 sub trees rather than one big tree, obviously it will be easier to find the data in 5 sub trees, independent trees, because each sub volume independently essentially is nothing but a tree, and that's how it works. So usually appears as subdirectory in the parent file system, can be mounted separately, not just as a subdirectory. Remember, advantages of subvolumes is not just this, because more advantages are, for example, it is similar to the 2 foreign file systems which are using the same pool of data blocks and other infrastructure. And the benefit is the different parts or the subvolumes of the file system can have different attributes. Remember, they will be treated as 2 different physical file system. You know what are the characteristics of physical file system? You cannot create hard links across file systems, and same is the case here. If you create a subvolume, you will not be able to create hard links across the subvolume. Please remember that. Same way you can implement the quota or snapshot rules. Like one subtree, you may not want to take the frequent snapshots. Another subtree or another subvolume, you may want that, yes, I want to implement some more rules, some frequent snapshots should be taken. So you can decide different policies for different subvolumes. So I would say for me, subvolume is nothing guiding tool to organize my data efficiently in a more efficient way. For me, subvolume is that, because it gives me a lot of advantages to organize my data so that they can have different features, different attributes, different quota rules, different snapshot rules, and not only that, they are treated as good as 2 different file systems, physical file system, even though you created them within one subdirectory. That's the best part of subvolume. That's a unique feature of subvolume. And still, copy on write is possible across volumes. That's also possible. Basic command line, as I told you, Btrfs subvolume, as I demonstrated, Btrfs subvolume. Mounting, mount -o subvolume is equal to volume name, subvolume name. So normal file system, to make the difference more clear, you can take a look at this Btrfs. We have root, and the entire data is organized under one tree or one file system. Root and some data blocks, somewhere opt is there, somewhere user is there, right? This is one file system tree. But when we say subvolumes, we can have 3 different sub trees. One is root, separate; user, separate subtree; opt, separate subtree. So if you convert them into subvolumes, if you treat them as subvolumes, they are independent subtrees. So the advantage is the organization. So it is better organized if you use this way. The advantage of subvolumes. The df versus Btrf file system. Df, which I demonstrated, there's a typo here, please forget that. Btrfs file system, actually, if you see on the title is a typo, so just ignore that. The df command does not show the correct amount of free disk space, as I demonstrated on the Btrfs file system. The appropriate way is built-in command with Btrfs command, which I demonstrated to you. Btrfs file system df and the path of the file system. Snapshots. Snapshots are nothing but copy on write. It's a copy on write on a full subvolume tree instead of a single file only. But remember, copy on write. So initially only the metadata is copied. The moment you start changing, they take different ways. Every snapshot is again a subvolume of its own. Snapshot as subvolume can be mounted, can be accessed as every other subvolume. So you can take it as another subvolume. Snapshots can be created read-only also, because why do we need to create that read-only? Why? Probably because if you want to take a backup, live backup, you simply create a snapshot, start taking the backup. That's easy way. Basic command line management is Btrfs Subvolume snapshot, which I demonstrated. I created the snapshot also. And these are commands which I already demonstrated. Btrf Subvolume create, we created it. Btrfs Subvolume set default, which I missed. You can take a look at that. Okay, the ID and the path. Btrfs Subvolume delete, you can delete this subvolume by giving the path or the name. For example, Btrfs Subvolume delete /data/sv4. Same way, Btrfs Subvolume list, you can list that also, and I demonstrated the list of subvolumes. I use that. Same way, Btrfs Subvolume find new, path or the name. Example, Btrfs Subvolume find new, the data and the ID you can specify. So you can find out the subvolumes. These are the command line utilities which I demonstrated, almost all of them, but yes, some of them I missed. You can try yourself also. Mounting subvolumes, as good as simple mounting. Mount -o volume name, subvolume is equal to name of the subvolume, and followed by the device. For example, in my case it was SDB and the mount point. I mounted that. Same way, subvolume can be mounted separately. So mount -o subvolume is equal to, this is how you mount it. There are two ways. One is you can mount using the name, another is you can mount using the ID, followed by the device and the mount point, like Btrfs Subvolume command parameter. Okay, this is how you can mount the subvolumes. Snapshot basics. Snapshot and the original point, original means of the original data, means the original subvolume, they point to the same block. I have been repeating it again and again. Snapshots reside on the same subvolume that has been snapshotted, are copy on writable, copy on writable, can be snapshotted again, that is snapshot of a snapshot is possible, are performed at the subvolume level. For example, subvolume makes snapshotting of Btrfs possible. That's the advantages of snapshot. I created it and I demonstrated, but yes, you can take it forward from this point. The features of Btrfs snapshot: single file rollback is possible, like you can do undo change. There are user interfaces like command line and the YAS2 integration is already there. Snapshot of YAS2 and Zyper activities possible. Automated snapshots are also possible, like you can create a configuration file where you can define the parameters and it will automatically take the snapshot as per your rules which you specify. Automated snapshot cleanup, like based on the time and number of snapshots which you want to keep, so it will clean up the snapshots accordingly. Allowed to work with several kernels, implemented independently of Btrfs on, right, in Zyp function. Rollback. There are two types of rollback. One is per subvolume, another is per file. Now this is per subvolume. Okay. Another will be file based, like undo change. How this works: instead of original subvolume, the snapshot is mounted with option subvolume is equal to subvolume name. Remember, because snapshots are subvolumes only. Talking about the root file system, the subvolume can also be hard coded using Btrfs subvolume set default is equal to that way. Benefits: atomic operation and very fast. Disadvantages: it increase the complexity, additional complexity, because it may require explicit mounting of the subvolumes, and no rollback per single file is possible because it is per subvolume we are creating the snapshot. No possibility of file rollback. Second is file based. How it works: the system uses the same instance of the subvolume known as working instance. Okay, single files are copied from snapshot to the working instance, that is using copy on write. Benefits: subvolumes are treated as read only. Subvolumes can be used for backup, support, pick and choose. Disadvantages are rollback not atomic. That's a disadvantage because it may require some more computing time. So this is two types of rollback of snapshots. Snapshotting the root. The challenge is, if you have multiple kernels, then yes, we need separate /boot for each. Zyper integration is a problem. System integrity and compliance don't allow to roll back certain log files, etc. But then that can be solved by using subvolume for each of these subdirectories like temp, opt, serve, where spool, where log, where run, where temp. That's a possibility. That's way out. Snapshotting the root, the traditional method. The root file system is mounted as any other Linux file system. Like root volume of Btrfs file system is equal to root in a user's view. Benefits: no difference for people coming from ext2, ext3 or xfs file system, and no self default or set default kind of thing necessary in this case. Disadvantages: subvolume based rollback introduces additional complexity, less flexibility for future improvements. For example, no parallel root file systems. The snapper command. This is a command line utility to take the snapshot. The CLI utility for file system snapshot management. The snapper can create snapshot, delete snapshots, compare changes between snapshots, undo changes between snapshots, and for each subvolume being snapshotted, a snapper configuration file must exist for that subvolume, created by the snapper create config command. Snapper distinguishes three types of snapshots. One is pre, second is post, and third is single. Okay, we'll understand three types of snapshots also. Snapper configuration stored into etc snapper configs. Let's take a look at this directory and take a look at the sample configuration file. Okay. So cd/et/snapper config. Okay, the file here is we have directory configs. Okay, and this is where we are. So we have one configuration available. Let's take a look at that also, whatever is available root. So this is the snapshot configuration file. So it is subvolume to snapshot. So subvolume is root, file system type is Btrfs, right? The group, space limit, allow users, allow groups, sync ACL, background comparison, number of cleanups, number minimum age, limit, and number limit important, and timeline create, that is hourly snapshots, cleanup hourly, right? Limits the timeline cleanup. So these are time based things. So this is an example configuration file. You can create snapshot configuration file for your own subvolume like this by using snapshot create config file, snapper create config, alright, which I demonstrated. For example, snapper create config. Let's try one. Okay, so for example, snapper list configs. Let's take a look at that. Snapper so right now only one file was available as I noticed, and we can create a config, snapper create config /btrfs, which we created. Oh, file already exists for that, but we created another subvolume rec space, right? Configuration already exists for that also, so we can take a look at that. That's not an issue. So right now concept is this is how we do. The command is important. All right, let's continue. I'm ignoring, I'm not going to deep do the troubleshooting right now. We can take a look at later on. Okay, so snapper command parameters: snapper -c config name create -d description. Okay, snapper list, and to take a look at the difference between two snapshots, you can take use the command snapper diff. So snapper diff snapshot number 1, snapshot number 2. Snapper diff file snapshot number 1. This is how you can take a look at the, and followed by snapshot number 2. Snapper rollback, this is how you can take a rollback. How you can do a rollback, snapshot, rollback, snapshot number 1, snapshot number 2, that way. Snapper undo change, same way, snapper -c config file delete snapshot number. This is how you can delete the snapshots manually. Okay, so let's take a look at the snapshot list. Snapper list. So these are the snapshots available. Okay, a lot of snapshots already available. You can delete the snapshots, you can manage the snapshot, you can compare the snapshots, and all these commands you can try with these snapshot numbers. Alright, the important files and directories: etc snapper, the main configuration directory; etc snapper configs, the directory containing configuration files for managed subvolumes; etc snapper filters, directory containing files that list the files and the directories that are to be filtered, ignored; and etc snapper config templates. This is the directory containing managed subvolumes configuration file templates. These are the important files and directories. We should take a look at that. Automatic snapshot creation. The snapper utility also automatically creates snapshot of defined subvolumes on a time-based interval with cron. Utilities such as Zyper, there's a typo again here, please forgive me. It is such as Zyper and Yast automatically create snapshots when they run. Snapper can also automatically clean up, delete old automatically created snapshot, and this is the file which I demonstrated to you. If you recollect, something similar like subvolume name, the name of the snapshot, name to snapshot, list of snapshots. So you can take a look at that, because I demonstrated this file, a run daily number of cleanups, right? The limit for number cleanups, right? The list of snapshots list, and finally we have the time-based snapshot configuration also, parameters, and pre-post snapshot configuration also. So the file is organized into these 4 main sections, and which I just demonstrated the file also, example file. And this is the last slide, snapper snapshot directory layout. When the snapshots are taken, we have this is the directory structure, snapshot directories, like we have .snapshot. Under this we have 2 files. One is the metadata, or which contains the snapshot description, and the files and directories of the snapshot, that is file single snapshot. Okay, then we have pre-snapshot, means the snapshot, files and directories, the information, and after you take the snapshot and you create some files, so we have just changed file, list of changes also. So file 2, like file 2 or the text file or the additional file, plus information and the snapshot. So we have pre-snapshot and post-snapshot. So these are the 3 things which we need to understand the layout: single snapshot, pre-snapshot, and post-snapshot. Okay, thank you very much for watching. Bye bye. Please send me the feedback on this email ID. I'll post it on my website rnsangwan.com. So the email ID is ramansangwan@gmail.com. To study online, join my portal www.theskillpedia.com. Thanks for watching. Bye bye.